So in this lesson, we're going to be finding out and proving whether or not a triangle is right angled or not right angled. Now, as you can see by the title, it's the Converse of Pythagoras. So we'll be using Pythagoras' theorem to work that out. When you were taught Pythagoras' theorem, you will have been told that it only works in right angled triangles. So this fact here, this statement, the c squared being the longest side, the hypotenuse, is equal to a squared plus b squared, the two shorter sides squared and added together, only works in right angle triangles. So we're using that fact to prove whether or not a triangle is right angled or not. So let's get started. So just going to jump in through a question and show you the strategy here. If c squared equals a squared plus b squared, we know this triangle is going to be right angled. So this is how we go about showing that and setting it out. So we're looking at the triangle here and we're trying to prove whether or not this is a right angle triangle or not. Now the key thing is to understand that in my general equation here, C relates to the hypotenuse and A and B relate to the two shorter sides. So before we begin, I'm going to talk about use this information. My longer side, or my left-hand side, relates to the hypotenuse. So the left-hand side relates to my hypotenuse. I'm going to do that as a standalone calculation. And the right-hand side of the Pythagoras' theorem relates to the two shorter sides. And I'm going to do that as a standalone calculation. Now, if this was a right angle triangle, 5 would be the hypotenuse because it's the longest side. So that would mean that c squared would be the same as saying 5 squared. And we know that 5 squared is 25. If this is a right angle triangle, A and B will relate to these two sides. So it doesn't actually matter. So a squared plus b squared is the right hand side of my general Pythagoras equation. And therefore, in this case, it would be 3 squared plus 4 squared. Now 3 squared is 9, 4 squared is 16, and that also adds up to 25. Now, since the left-hand side of my calculations is equal to the right-hand side, we know that Pythagoras' equation has worked for this triangle. So since the left-hand side and equals the right-hand side, we state by the converse of Pythagoras the triangle is right angled. So if you have all three sides of a triangle and you're asked to prove if it's right angled or not, you just use Pythagoras' theorem and you split into two calculations, left hand side and right hand side. If they equal each other, you can say by the converse of Pythagoras, the triangle is right angled. So here's another question. Given this triangle's sides length 4, 5 and 7, is the above triangle a right angled triangle? So let's prove it, or not prove it, or disprove it, excuse me. So what we do is we know that c squared equals a squared plus b squared for right-angled triangles. Okay. So let's split it into two parts. The left-hand side and the right-hand side of that equation. Left-hand side is c squared, which is the longest side squared. So that would be 7 squared in this case. And that calculates out to being 49. So if this is a right angle triangle, we know that the right-hand side of Pythagoras' equation will equal 49. So let's try it. The right-hand side of the calculation is a squared plus b squared, which becomes 4 squared plus 5 squared, which works out to be 16 plus 25, which equals 41. Now, the left-hand side does not equal the right-hand side. So, therefore, by the converse of Pythagoras, the triangle is not right-angled. Ooh. Always make that statement and write your conclusion at the end, all right?